In the following dimensional analysis examples, we're going to be converting units that are not one-dimensional. We're going to work with things that are 2D, things that are areas, and things that are in 3D, like volumes. In our first example, we'll handle area. A circle has an area of 2,959 centimeters squared. What is that area in square meters? Okay, so the first thing that I want to do is conceptualize what's going on. I'm thinking of a square that has a total area of, this giant number, 2,959 centimeters squared. Well, if I'm going to call this something in meters squared, I'm not just going to need to know how many centimeters are in a meter, which is 100, by the way. But if I had a totally different area in mind, let's say I just had 1 meter squared in mind, I would have 100 centimeters and also on my other side 100 centimeters. That would make it so that 1 meter squared is actually equal to 100 centimeters times 100 centimeters. So that means that 1 meter squared is equal to 100 squared centimeters squared, not just plain old 100 centimeters. Okay, we're ready to set up our dimensional analysis now that we have thought about how to handle our area units. We have 2,959 centimeters squared. And we want those to turn into meters squared. So I will do my 100 squared centimeters squared and my 1 meter squared. And that should equal my final answer. I've done a little bit too much bar, so I'll have to erase a little bit. Okay, triple checking dimensional analysis time, making sure I didn't put my units on the wrong spot. Centimeter squared, everything's good to go. Plugging it into the calculator, I get 0.2659 meters squared. In this next example, we're going to handle a 3-dimensional unit. Okay, let's see. Earth's oceans contain approximately 1.36 times 10 to the 9 kilometers cubed of water. Wow, that's quite a bit. Let's calculate that volume in liters. Okay, so how the heck am I going to go from kilometers cubed all the way to liters? Okay, well, I've heard of some other kinds of units in between. I've also heard of milliliters. I also saw on a cheat sheet somewhere that a centimeter cubed was equal to a milliliter, so I could use that equality. Oh, okay, here we go. I see I have kilometers here and centimeters, and in between those, my mini step could possibly be meters. Yeah, okay, I see a plan forming. Those meters need to be cubed, though. Okay. All right, next thing. I'm trying to find out how many of each of one of these things equals each other. Okay, so I'm just going to pretend I have a cube and that I have 1 kilometer on each one of these sides of this cube. If I have 1 kilometer, that should equal 1,000 meters. But it's happening in 3D. So I have 1,000 meters, 1,000 meters, and 1,000 meters. Which means that 1 kilometer cubed should equal 1,000 cubed meters cubed. Okay, that's kind of insane. We got to do the same thing for meters and centimeters. It would follow the same kind of logic. The 1 meter cubed should equal the regular old number 100 centimeters, but cubed for centimeters cubed. Okay, now we have everything we need to go from kilometers to meters to centimeters. which are all cubed into an already pre-cubed unit, milliliters to liters. Okay, let's set up the dimensional analysis. This one's going to be long. So we're going to start with 1.36 times 10 to the 9 kilometers cubed. Okay. The next thing, I need to put my kilometers cubed on the bottom, so I'll use this next equality. 1 kilometer cubed, and that's equal to 1,000 cubed meters cubed. The next one is getting rid of the meters, so I'll go and convert those meters into centimeters. 1 meter cubed is equal to 100 cubed centimeters cubed. Glorious. Okay. Now I'll use that equality from my cheat sheet. 1 centimeter cubed is equal to a milliliter. And I know from looking at water bottles that 1,000 milliliters is equal to a liter. Okay, now to really carefully calculate this one. Go ahead and practice in your calculator and make sure that you end up with the same answer that I'm getting, which is 1.36 times 10 to the 21 liters. Okay, with that insanity down, you are now ready to tackle dimensional analysis in 2D and 3D.